In this lesson, we will start to solve radical equations, and we are only going to focus on radical equations that have one radical for this lesson. So here's our steps, and they're going to be the same steps for all of our lessons on solving radicals. The first thing that we want to do is to isolate the radical. So hopefully we just have one radical, we get everything else on the opposite side of the equal sign. That's ideal. If your equation has more than one radical, you have to choose one of the radicals to isolate, so just pick one and go with it. Then you're going to raise each side of the equation to a power equal to the index. So if it's the third root, you're going to cube it. If it's the square root, you're going to square it. If it's the fourth root, you're going to take it to the fourth power. You're going to solve the resulting equation and hopefully find a solution. If you still have a radical, however, you have to repeat steps 1 and 2. Then you have to check the potential solutions in the original equation, because sometimes you end up with things called extraneous solutions, which means you found them to be solutions, but when you plug them back in, they don't work. So these are solutions that don't work. So they should work, but they don't. So this is potentially going to occur when the equation is raised to an even power. For my first example, this is fairly straightforward. I'm just going to isolate the radical x. So I'm going to subtract 3 from each side. I'm trying to get radical x all by itself. 5 minus 3 is 2. Now I want to square that. Now why did I choose to square it? Because the index is 2, and I know if I square something that is the square root, I end up with whatever was inside. So the square root of x squared is x. And 2 squared is, of course, 4. And then we would, of course, check the solution. So radical 4 plus 3, does it equal 5? Radical 4 is 2, and 2 plus 3 does, in fact, equal 5. And so it worked out. Again, we did take this to an even power, so that's the ones where we have to be careful. Let's try another. So in this question, again, I'm trying to isolate the radical, so I'm going to add 1 to each side. That gives me the cubed root of x plus 2 equals 3. The index is 3, so I'm going to choose to cube each side. When I cube this, I get everything that was on the inside, so I get the radicand. 3 cubed is 27, and then I'm going to subtract 2 and get x equals 25. Now let's take a look to see if we end up with an equation that works. So I'm going to check the cubed root of 25 plus 2 minus 1. Does that equal 2? 25 plus 2 is 27. The cubed root of 27 is 3. And 3 minus 1 is 2, and so it checks out. For my next, I'm going to subtract 5 from each side to isolate the radical. So I have the fourth root of x plus 2 equals negative 2. I'm going to take this to the fourth power. On this side, I get x plus 2. On this side, negative 2 to the fourth gives me positive 16. And then, of course, I'm going to subtract the 2 from each side, so that gives me x equals 14. When I check the solution on this one, we're going to see that we have a little bit of a problem. So 14 plus 2 plus 5 equals 3. So 14 plus 2 is 16. And the fourth root of 16 is 2. But 2 plus 5 does not equal 3. So this is where we have to be very careful. And you could have, at this point where I moved this 5 to the other side, we had the fourth root of x plus 2 equals negative 2. At this point, before I took each side to the fourth power, I could have looked at this and said, well, I'm taking an even root and I'm getting a negative value, and I know for sure that's not going to work. But if I get to this point and I solve it and find that x is 14, I know that when I plug it back in, obviously that's not going to work out. Let's try another. This one's written differently, but it's just written with a rational exponent rather than inside the radical. I'm still going to follow the same steps. 3 minus 6 is negative 3, and this is x minus 1 to the 1/4. Of course, to solve this, I would take each side to the fourth, because 1/4 times 4 would give me 1. So that would give me negative 3 to the fourth, which is 81. X minus 1 on this side. I would then add 1 to get 82. And I get my answer of 82. Now, again, at this step, I should have stopped and said, I'm taking the even root and getting a negative value, so I know I'm not going to get a solution. But in case I didn't see that, then we just plug it back into the original. 6 plus 82 minus 1 to the 1/4. 82 minus 1 is, of course, 81. The fourth root of 81 is 3. And 3 plus 3 3 plus 6 is not 3. So this is not a solution. So this would be no solution. On this question, as you can see, we have a little bit more going on. We have a value out front and a value that's being subtracted. And in addition, it's an x, which makes it more complicated. I am going to go ahead and add that x to each side because remember, I'm trying to get the radical by itself. So that leaves me with 2, and then the square root of x plus 3 equals x plus 3, or 3 plus x. I tend to write the variable first. Now, I have a choice here. I can either divide each side by 2, which of course is going to give me a fraction on this side and give me my radical by itself, or I can simply remember that when I am squaring this, that the 2 will also be squared. So when I square each side, I get 2 squared, which is 4, and then I get parenthesis x plus 3. So this squared, the square root and the squared canceled out. But I did have to square the 2. On this side, I have x plus 3 quantity squared, which means I'm foiling it out. This is a perfect square, so I know it's the first term squared, it's twice the product of the 2 terms, and it's the last term squared. On the left side, I'm just going to distribute that 4, so that gives me 4x plus 12, and then x squared plus 6x plus 9. Now, just as a side note, if I would have decided to divide this by 2 and divide this by 2, I would have ended up with all of this over 4, and then I would have had to multiply it by 4 anyway to get it off of the right side and make it not a denominator anymore. So I really saved myself work by leaving that 2 out front. I am going to go ahead and subtract the 4x from each side and the 12 from each side because I know this is a quadratic, and therefore I'm going to set that equal to 0. So now I end up with x squared, and then 6x minus 4x is 2x, and then 9 minus 12 is minus 3. I'm running out of room, so I'm going to come back up here and we'll check our solution in a bit. That leaves me with 0 equals x plus 3, x minus 1 if I factor correctly. Remember, you can always check it in your head. That would be minus 1x and plus 3x, which is plus 2, and those multiply to negative 3. Finding my solutions, I would set each of those equal to 0. So x plus 3 equals 0 gives me negative 3. X minus 1 equals 0 gives me positive 1. This was one of those even questions, so I ended up squaring each side. So that's very possible I end up with a solution that doesn't make sense. So I'm going to check my solution using these 2 values. You can start with the original equation, or you can start with the equation once you moved the x over. So I'm going to start with 2, and then the square root of negative 3 plus 3 minus x, so x would be negative 3 equals 3. Negative 3 plus 3 is 0. Square root of 0 is 0 times 2 is 0. And that gives me minus negative 3 equals 3. So 3 equals 3, which checks out. So this is a solution. For the 1, I'm going to do the same thing. So square root of 1 plus 3 minus 1. 1 plus 3 is 4. The square root of 4 is 2 times the 2 that was already there. So I get 4 minus 1 equals 3. 4 minus 1 is 3. And so this one, I do end up with 2 viable solutions. So no extraneous solutions on that question. Try this question on your own and then press play to check your work. So on this question, again, I'm trying to isolate my radical, so I'm going to get rid of y. Move it to the opposite side. That leaves me with 2 radical 4y minus 3 equals negative y plus 3. I'm not loving that. I could also write that as y minus 3. It doesn't matter. Again, I can choose to divide by 2, but then when I square it, then I'm squaring a fraction and it gets ugly. So instead, I'm just going to square it as is. The 2 squared will of course give me 4. This whole mess squared is going to give me that whole mess again. So the radicand stays the same because the index and the exponent cancel out. On this side, I'm multiplying negative y times negative y, which is positive y squared. Remember, this is just like foiling negative y plus 3. And I'm going to end up with minus 6y and plus 9. On the left side, I have 16y minus 12. And all of this mess over here. I'm going to subtract the 16y from each side. I'm going to add the 12 to each side and see what I have left. That leaves me with 0 equals y squared minus 22y and then plus 21. Again, I'm running out of room, so up here I go. I'm going to factor into terms that multiply to 21 that add to negative 22, which would of course be negative 1 and negative 21. Those would multiply to a positive but add to negative 22. Setting each of those equal to 0, I would end up with y equals 1. And of course, adding 21, I would get y equals 21. So those are my 2 possible solutions, and then I would plug them back into the equation to see if they work. So 1 plus 2 radical 4 times 1 minus 3, does that equal 3? 4 times 1 is 4, minus 3 is 1. The square root of 1 is 1, so I multiply that by 2. So I get 1 plus 2 equals 3, which of course means 3 equals 3, and it checks out. So this is a solution. For my other one, for 21, I have 21 plus 2, and then 4 times 21 minus 3 equals 3. I'm running out of room here. 4 times 21 is 84, minus 3 is 81. The square root of 81 is 9. 9 times 2 is 18. 21 plus 18, not equal to 3. So that is an extraneous solution, so my only solution is y equals 1.